Other chemical companies on some high-rise buildings in London where they incorporate polypropylene fibres, also with Barden Concrete, or London Aggregates as they know, London Concrete. They've done lots of buildings in London. They incorporate polypropylene fibres, solely to reduce the risk of explosive spalling in high-rise buildings. Bridges. In some countries, they define a tunnel. If you've got a road passing underneath a bridge, it constitutes a tunnel, so they have to protect that from the risk of explosive spalling. So in case a petrol tanker gets stuck under the bridge, explodes, obviously that bridge would be not serviceable. Cable tunnels. Every cable tunnel in the UK contains polypropylene fibres. There's miles and miles and miles of cable tunnels laid every year, hundreds of thousands of cubic metres of concrete, all containing polypropylene fibres, and that's to reduce the risk of damage. Underground and multi-storey car parks as well. Across Europe, where you've got underground parking, a car goes up in flames, your column loses its strength, you get explosive spalling, the steel starts to melt and weaken at about 700 degrees centigrade, and you get structural failure. So in a lot of areas across Europe and the world, microfibres are being used for this. This is the main purpose now. In the past, it was durability, freestore, plastic shrinkage cracking. Some of the jobs that we've been involved in, it's just a list, you can see they're all over the place. Norway, Kuala Lumpur, Westerschelde Tunnel in Holland, Airside Tunnel at Heathrow Airport, Kentish Town Cable Tunnels. The Crossrail project in London, all the new tunnels, it's costing £15 billion, or it is at the minute. That's all got microfibres in it. They've also got, what I'm going to talk about next, is macrofibres in some of the sections. Other areas of use of the microfibres. Britpave in about 2000 specified the use of microfibres for all extruded barriers. So all the barriers that you see being done on the motorways, the M5, M6, M1, M25, hundreds and hundreds of miles of these particular ones being done over the last 5 years, they've all got microfibres in. And it's there for durability and longevity of those particular structures. Aggressive environments. Typical areas, sea defence and marine structures. Everybody knows that Grace have done a very good job at promoting how well they did at Blackpool Sea Defence. They put their macrofibres in the concrete to replace all the steel reinforcement. Brilliant. It also had microfibres in it, and that was for durability purposes. So on that particular project, you've got a combination of macrofibres and microfibres. It's also possible to combine steel fibres, steel mesh, with micro and monofilament microfibres. Aggregate storage areas. Lots and lots of concrete companies all over the country. When I was at Tarmac, we'd always use microfibres in the concrete because it increased the abrasion resistance and longevity of the concrete. And Ian showed you earlier, new plant in Plymouth, that has also contained macrofibres for the same benefits. Areas of continuous erosion. You've probably all heard of Burst Coastal. They do big sea defence projects all over the country. They always, as standard, incorporate a microfibre in their mixed concrete formulations. They also use a macrofibre where it's feasible to use it. That's the Blackpool Sea Defence. Miles and miles, I think there were 300,000 cubic metres of concrete. No steel in that whatsoever. It's just a combination of micro and macro fibres. And that particular model has been replicated all over Europe. Another big area, external concrete slabs. Reduce the risk of plastic shrinkage cracking, increase abrasion, increased impact resistance, added freestore benefits. You can use this product in conjunction with air and train concrete or air and train concrete by itself. Just depends which method you want to choose. I'm now going to touch on macrofibres. Macrofibres have been with us probably for the last 10 years on a very, very small scale. Since about 2003, it's increased exponentially. There's now in the region of 50 million cubic metres of concrete per year using macro-synthetic fibres globally. It's used in anything from precast factories, ready-mix concrete for external, internal slabs, walls, precast systems, you name it. If it's possible to use it, we can do a design. And David, who's at the back and we'll be talking next, he's our engineer. He designs the use of our fibres into systems. So if you use it, it's PI'd, it's warranted. You should also be looking for a CE mark for these particular types of fibres. It's a guarantee of consistent quality. They might be consistently rubbish, and some products are. The ones that we do, and I think Ian will tell you, we've developed a new fibre, Durus S300. It's easy to mix, which is good for the ready-mix people, you don't get bowling. It's easy to finish, it's good for the contractor. And from an engineering perspective, it's good because you haven't got to design using 2, 3, 4 layers of mesh, which then make it impossible for the contractor to use, and it increases the cost to the end user. Ian touched on this earlier, I'm not going to spend much time on it. No site health and safety problems. We did a large job with Snowdon flooring back in October 2010. And it finished in, I lost track of my years, that's all. As you get older, you do. And basically, it saved them 1 month on their programme time. It was a multi-storey car park covering 25,000 square metres. This was done in conjunction with Barden Concrete. So Barden supplied the concrete, Snowdon Flooring laid the floor, and they didn't have to add any mesh. The specification was a 70mm concrete screed on top of concrete planks. 70mm on top of concrete planks. It was 25,000 square metres. It saved them 1 month on the programme time. So they opened the car park early, and the NCP were very happy because they could take money earlier. Less manual handling. Everybody, every company has problems with manual handling. Lifting boxes, lifting mesh, lifting briefcases out of the backs of cars. The more lifting people do, the more chance they've got of hurting themselves. Also, steel mesh can and often is badly placed. As a concrete technology, when I work for Tarmac, every week I go on a problem, plastic shrinkage cracking. What's caused that? Well, why don't you put some fibres in it? That'll solve that problem. Good. Misplaced mesh. Everybody knows about a job where some fibres have been used and it goes wrong. Nobody talks about where the mesh has been used and it's gone wrong. And the problem is, it's both the same problem. It's either been badly designed or the materials have been badly used. So they've used it in the wrong location or the wrong way. It also shows you from Ian's videos, which were really good, speed of construction. If you can construct a slab twice as quick with half the people, it's more cost effective, so it gives your company, if you're a floor layer, an advantage. There are different types of macro fibre, and very often we get rang up and say, well, we're not using macro fibres, they're rubbish. We've got bits of fibre stuck at the surface, we can't finish it. And it's true, there's different types of macro fibre. We do all three, so you can have any one of them. And I can tell you the ones that lay better and are easier to use. There's the first type, which is what's called a crimped sinusoidal wavelength macro fibre. These are typically 40 to 50 millimetres in diameter. Sorry, 40 to 50 millimetres long, not diameter, and about 1 millimetre in diameter. They typically come in pucks. They come in pucks, these are called fibre pucks. The pucks named after sort of high socket pucks. Nice and small, they weigh about 200 grams, 250 grams each. And we put them in pucks because it makes it easier to transport. So the idea with these fibres, going back to what Ian was saying about sustainable development, is on one truck you can get 22 pallets with 22 tonnes on a truck. The equation is simply 1 kilo of macro fibres to probably 4 kilograms of steel fibres. So if you've got a contract where you're needing 100,000 cubic metres of concrete, you can probably have 4 trucks of this delivered to something like 20 trucks of steel fibre. So the saving in terms of energy and the green credentials are enormous. The next type of product is called a flat sheet tape. And basically we do one called S200, Grace Construction Chemicals do one called Grace Strux, Propex, another one of our competitors, they call it something else, 650S. They're very, very good products. They give very, very good beam tests, good flexural strength, but the downside of that product is it's difficult to mix and it's difficult to finish. So if you want good performance, you're not bothered about the finish, that's the product to use.